Let's go back to our old pizza model, and let's say there's a pizza and that's cut into, let's say, 8 equal pieces. Once again, I'm trying my best to make them look equal. If they aren't, please assume all the pieces are the same length, same size. Let's say I eat 3 out of those 8 pieces. So I eat this, this and this. After some time, I feel more hungry. I eat this and this. So that's 2 more pieces, 2 out of 8. So I eat another 2/8. And the question is, what fraction of the pizza have I eaten in all? That means essentially, I add up the 2 parts that I've eaten. I add up 3/8 with 2/8. Now what's 3/8 plus 2/8? Do we add the numerators together, get a 5 on the top, and add the denominators together? 8 plus 8 is 16 on the bottom. Look at the picture to answer that question. What fraction of this circle has been ticked? 1, 2, 3, 4, 5 out of 8 pieces. So, I have eaten actually 5 out of 8 or 5/8 of the whole, which means when you add 2 or more fractions, you could extend this idea with more than 2 fractions. You only need to add the numerators. 3 plus 2 is 5. But the denominator stays the same as long as the fractions are on the same denominator. Similarly, if I were to cut a pizza into 3 equal pieces and eat 1/3 of it now, 1/3, and eat another 1/3 of it later, another 1/3, the fraction of the whole pizza I would have eaten is 1/3 plus 1/3, and as we can see from the picture, it's 2 parts out of 3 that's shaded, so this is 2/3. This isn't 1 plus 1 over 3 plus 3, it's 1 plus 1 over 3. So the denominator stays the same. You only add the numerators. This is how you add fractions on the same denominator. And like I said, you could extend this idea to more than 2 fractions. So for example, if you were to add, let's say 3/10 with 1/10 with 5/10, which of course simplifies to 1/2. 5 over 10 is the same as 1 over 2, but we will keep this form in this problem. So 3/10 plus 1/10 plus 5/10 is going to be 3 plus 1 plus 5 on the top, all over the same denominator 10. So this is going to give you 9/10. Sometimes you might need to reduce or simplify your final answer. For example, if you had to add, let's say 2/15 with 4/15 with 3/15, let's say. So you get on the top 2 plus 4 plus 3 all over 15, which is 9/15, and 9/15 can be simplified. You can divide 9 with 3 and 15 with 3. So that becomes 3 over 5. So the simplified form of this sum is 3/5. How about subtracting fractions? Let's say you order a pizza. You cut it into, let's say, 6 equal pieces. Something like this. We have 6. Let's just assume the pieces are equal in size. And you are about to eat 5 of these 6 pieces. So you're about to eat this, 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 and this. So you're about to eat 5/6 of the pizza, and even as you are about to eat it, your friend comes over and you need to give away these 2 pieces to your friend. So essentially, you end up eating 5/6 minus 2/6 of the whole pizza. And the question is, how much is 5/6 minus 2/6? Once again, if you look at the picture, you end up eating 1, 2, 3 pieces out of a total of 6. The total is still 6. So you will have eaten 3 out of 6 pieces. That's 3/6 of the whole. Once again, to subtract fractions, just like we did with addition, you only subtract the numerators. The denominator is the same. And in the same way, 7/10 minus 3/10 is going to give you 7 minus 3, which is 4 over 10, 4/10. And that can be simplified. You can divide 4 with 2 and 10 with 2. You end up getting 2/5. And you can actually add and subtract more than 2 fractions in the same way. So if you were to do, let's say, 3/5 plus 1/5 minus 2/5, you would end up getting something over 5. And on the top, you have 3 plus 1 minus 2, which is 4 minus 2, 2 over 5, 2/5. That's pretty much how you add or subtract fractions of the same denominators. But how about if the denominators on the fractions that you're adding or subtracting are not the same? How do you add, for example, 1/4 to 2/5? You could do a 1 plus 2 on the top. But then how about the denominator? Is it going to be a 4 or is it going to be a 5? You know how to do it with the same denominators, but not with different denominators, right? So then, let's try and get to what we know. Is there a way to make the denominator same? And the answer is yes, we could, by using 2 concepts. One is called the LCM, or the least common multiple of these 2 numbers. The least common multiple, LCM, least common multiple, is the smallest number that is a multiple of both 4 and 5. And the multiples of 4 are like 4, 8, 12, 16, 20, and so on. And the multiples of 5 are 5, 10, 15, 20, and so on. So 20 is the smallest number that is a multiple of 4 and 5 both. So your first job is to find the LCM of the denominators. It's also called the least common denominator of the 2 fractions. So LCM of the denominators is also known as the LCD, least common denominator, D for denominator. Of the fractions. So we would say 20 is the LCM of 4 and 5, or we would say 20 is the LCD of 1/4 and 2/5. And our job is to make use of our knowledge on equivalent fractions and change both of these numbers to 20. And how can we do that? Well, multiply 4 with 5 to get a 20. And then if you do that, remember, to keep the fraction the same, you can change this fraction, right? Should be the same. You can change the problem. So you need to multiply the numerator also with the same number to make sure you're still working with an equivalent form of 1/4. In the same way, you want to change this to a 20 multiplied 5 with 4 and 2 with 4. So the new fractions that we get are 5 over 20 and 8 over 20. Add them up. Now you know what to do. They are on the same denominators. Therefore, the answer is going to be 5 plus 8 all over 20, which is 13 over 20. Therefore, 1/4 plus 2/5 is 13/20. It looks a little odd with fractions, I know. 1 plus 2 is nowhere near to 13, nor does 4 and 5 add up to give you 20. But that's how it is with fractions. And the rules stay the same when you want to subtract. So you want to subtract 2/3 from 3/4. They aren't on the same denominator. So your first job is to change them to the same denominator. The LCM of 4 and 3 is 12. So we need a 12 over here. We need in place of 3/4, we need one of its equivalent forms that has got a 12 at the bottom, and same goes with 2/3. We need a 12 on the bottom, and then we should subtract them. Which means we need to multiply 4 with 3, and when you do that, please also do the same with the numerator. So we have a 9 over 12, and then this 3 multiplies with 4 to give you a 12. So you need to multiply 2 with 4 as well. You get 8 on the top. And therefore, this is 9 twelfths minus 8 twelfths, which is 9 minus 8 all over 12, which is 1 twelfths. So 3/4 minus 2/3 gives you 1 twelfths. Once again, looks odd, but that's how it is with fractions. Want to add or subtract more than 2 fractions? Let's see how. Let's say we want to do 1/2 minus 2/3 plus 4/5. 3 fractions, both addition and subtraction. Okay, so your first job is to change the 3 denominators to the same number. That is to say, find the least common denominator or the LCD of the 3 fractions. In other words, find the LCM or the least common multiple of 2, 3 and 5. Well, the LCM of 3 and 5 is 15, but 2 doesn't go to 15. Therefore, you can't change these numbers to 15. The next best option is 15 times 2, which is 30. 5 goes into 30, 3 goes into 30, and 2 goes into 30 as well. So our number is going to be 30. So we are going to change this to something over 30, change this to something over 30, put a minus in between them, and then a plus. Change this to something over 30. 2 times 15 is going to give you 30. So multiply the numerator with 15 as well. 3 times 10 is going to give you 30. Multiply the numerator with 10. 5 times 6 is going to give you 30. Multiply the numerator with 6 as well. So we end up getting 15 over 30 minus 2 times 10 is 20 over 30 plus 4 times 6 is 24 over 30. So it's something over 30. 15 minus 20 plus 24. You could add 15 with 24 first. That gives you 39 minus 20. 39 minus 20 is 19. So this answer is 19 over 30. And this is a 10. Does that help? Before we go on to talk about how to add and subtract mixed numbers, let's quickly talk about how to compare fractions. Now, like I said, fractions are like normal numbers and they can be represented on a number line. And therefore, they can be compared pretty much in the same way as we compare numbers. Let's say I have eaten 2/3 of a pizza and you have eaten 3/4 of another pizza of the same size. And the question is, who has eaten more amount of pizza? Or in other words, which of these 2 fractions is more? Look, there are different ways to compare fractions. I'm going to show you one of those ways, one short way that will tell you which of the 2 fractions is more. But before we get into this problem, I have a different question for you. Can you tell me between 2/3 and 1/3 which is more? Or can you tell me between 3/4 and 1/4 which is more? Now 2/3 means cut the whole into 3 equal parts and then combine 2 of those parts or pieces together. On the other hand, 1/3 means cut the whole into 3 equal parts and then take only one of those 3 parts. So obviously 2 parts out of 3 parts will be more than 1 part out of 3 parts, provided the 3 parts are all the same size. Reason why I said the pizzas need to be the same size. You cannot compare 2/3 of a small pizza with 1/3 of a large pizza. Similarly, if you cut the whole into 4 equal parts and you eat 3 of those parts, That will give you more amount than cutting the whole into 4 equal parts, the same whole or the same size, and eating only one of them. So what's the bottom line? The bottom line is, when two fractions are on the same denominator, you can just compare the numerators and figure out which is more and which is less. Because this is a 3 and this is a 3, 2 is larger than 1, therefore 2/3 is going to be larger than 1/3. We have a 4 and a 4, 3 is more than 1, therefore 3/4 is more than 1/4. But how about here? The fractions aren't on the same denominator, and you might have already guessed it, we do the same thing as we do with adding or subtracting fractions. We make the two fractions the same denominator by using their equivalent forms. So the LCM of 3 and 4 is 12. Our job is to rewrite 2/3 as something over 12, that is, use one of its equivalent forms in which 12 is the denominator, and because 3 can go into 12, we can do that. Similarly, change 3/4 to something over 12 and then compare. 3 times 4 is 12. You want to multiply the numerator with 4 as well, so that you make sure that the new fraction is equivalent to this one. So we have 2/3 is equivalent to 2 times 4 is 8. So we have 8 over 12. And on the other hand, multiply this with 3. 4 times 3 is 12. Multiply 3 with 3. So this becomes 9/12. And 8/12 is smaller than 9/12. And that in turn means that 2/3 is smaller than 3/4. Another one. Let's try and compare 5/8 with 6/10. The denominators are different. The LCM of 8 and 10 is not 80, it's actually 40. So we are going to rewrite this as something over 40, and this is a 10. So this as something over 40. 8 times 5 is 40. Therefore, multiply 5 with 5. You get a 25. On the other hand, 10 times 4 is 40. Multiply 6 with 4. Because you're using one of its equivalent forms, you don't want to change the fraction. And 6 times 4 is 24. 25 is more than 24 on the same denominators. Therefore, 25/40 is more than 24/40, which means 5/8, which is nothing but the same as 25/40, is more than 6/10, which is nothing but the same as 24/40. This is how you compare fractions. I would say this is one of the ways how you compare fractions. There are other ways. Okay, so let's move on to adding and subtracting mixed numbers. How do you add, let's say, 1 and 3/4 with 2 and 1/10? Well, recall that 1 and 3/4 means 1 whole and, or a plus, there's a small plus here that we don't write, it's implied. It means 1 whole and 3/4 from the other one. Similarly, 2 and 1/10 means 2 wholes and, or a plus, 1/10 from another one. Therefore, in order to add them, we could add the wholes together. So 1 whole plus 2 wholes will give you 3 wholes, and add the fractions together. So that's going to be 3 wholes plus 3/4 plus 1/10. And you know how to add fractions that are not on the same denominator. The LCM of 4 and 10 is 20. Therefore, we are going to rewrite this as something over 20 plus this as something over 20 and add them up. And finally, add that result to the 3 wholes we got. Now, how many times does 4 go into 20? 5 times, right? 4 times 5 is 20. Therefore, do the same with the 3 on the top. That gives you a 15. And then 10 times 2 is 20. Do the same on the top. 1 times 2 is 2. So this is equal to this, and this is equal to this, and that's equal to 3 wholes plus, combine these two, all over 20, 15 plus 2, that's 3 wholes plus 17 over 20, or in other words, this is the mixed number 3 and 17/20. This is one way of adding mixed numbers together. The other way being, change each of the mixed numbers to improper fractions and add them up. So if you do 1 and 3/4, let me just quickly show you that other way also. So 1 and 3/4 is going to be 1 times 4 plus 3, remember? So that's 4 plus 3, that's 7/4. And then you have 2 and 1/10 as 2 times 10 plus 1, that's 20 plus 1, that's 21/10. So you add 7/4, you add 7/4 plus 21/10. Change them, 4 and 10 changes to 20. So you have over 20, you have over 20, plus multiply this with 5, multiply 7 with 5, multiply 10 with 2 to get a 20, and multiply 21 with 2. 7 times 5 is 35, 21 times 2 is 42. So we have 42 plus 35, that's 77 over 20. Change it back to a mixed number. Divide the numerator with the denominator. 20 goes 3 times into 77. 20 times 1 is 20. 20 times 2 is 40. 20 times 3 is 60. 20 times 4 is 80, and that's over 77. So we are going to write a 3 over here. That's the quotient. And the remainder is 17 over 20. That's exactly what we got using the other method. Usually this method, the first one I showed you, is more common, and therefore we are going to stick to this. Let's try another one. Let's say you want to do 3 wholes and 4/5 plus 4 wholes and 2/3. So let's add the numbers together. I mean the whole numbers. 3 plus 4 is 7, plus we have a 4/5 plus a 2/3. The LCM of 5 and 3 is 15. Therefore, this is going to be 7 wholes plus something over 15 plus something over 15. 5 times 3 is going to give you 15. Therefore, you want to multiply 4 with 3 to get a 12 over 15. 3 times 5 is 15. Multiply 2 with 5, you get a 10 over 15. And therefore, this is 7 wholes and 12 plus 10 over 15. So this is 7 wholes and 22 over 15. Now look at 22 over 15. What type of a fraction is this? This isn't a proper fraction. This is an improper fraction, which means this has also got 1 or more wholes in it. Therefore, we are going to change 22 over 15 to a mixed number and add it back to the 7. Let's go. So this is 7 and 22 over 15. Divide 22 with 15. You get 1 whole. The remainder is 7. 7/15. Add the wholes together. 7 wholes and 1 whole is 8 wholes in all. So the answer is 8 and 7/15. So remember, a mixed number like this can never have the fractional part as an improper fraction. The fraction in any mixed number has to be a proper fraction. If you get an improper fraction, you need to do this and change it over to a mixed number and add the whole to the whole that you have on the number. Let's talk about subtracting fractions. Pretty much the same way. Let's say we want to do 2 and 3/5 minus 1 and 1/2. 2 wholes and another 3/5. from the third minus 1 whole and another 1/2. So 2 wholes minus 1 whole is going to give us 1 whole. So we have 1 whole in our answer. And then we need to do 3/5 minus 1/2. That is, subtract the wholes and subtract the fractions. You get your answer. Now what's 3/5 minus 1/2? Obviously they are not on the same denominator. Our job is to find their LCM, the LCD of 3/5 and 1/2, which is 10. So we are going to change this to over 10 and 1/2 to over 10. We have 1 plus 5 times 2 is 10, therefore multiply 3 with 2. You get a 6 on the top, 6 tenths, minus 2 times 5 is 10, 1 times 5 is 10. Therefore you have a 5 on the top. So we have 1 whole plus 6 minus 5 over 10, all over 10, which is equal to 1 whole and 1/10. So 2 and 3/5 minus 1 and 1/2 gives you 1 and 1/10. Pretty simple, right? There's a little twist to the story. Now imagine you want to do 4 and 1/3 minus 2 and 3/4. Like I said, subtract the wholes. 4 minus 2 is going to give you 2 wholes. That's fine. And then subtract the fractions. 1/3 minus 3/4. They aren't on the same denominator. So time for us to change them. Okay, fine. LCM of 3 and 4 is 12. So we have 2 wholes and something over 12 minus something over 12. 3 times 4 is 12. Multiply 1 with 4, you get a 4. 4 times 3 is 12. Multiply 3 with 3, you get a 9. And now there's a problem. This is 2 wholes and 4 minus 9 all over 12. 4 is smaller than 9. So that's going to give you a negative number. What do? Remember borrowing in subtraction? That's exactly what we are going to do. Now because we figured out that 4/12 is smaller than 9/12, so 4/12 is not good enough to subtract 9/12. It needs help. It needs to borrow. From whom is it going to borrow? From this 2 wholes. The 2 wholes changes to 1 whole because it's going to lend 1 whole to this 4/12. Now I have a question. The 1 whole that goes to here, this 4/12, can be written as how much over 12? In other words, I'm asking you, what over 12 is equal to 1? Recall that this is nothing but division. So it's like saying a number divided with 12 is 1. And obviously that number has to be 12. 12 divided by 12 gives you 1. In other words, think in pizza terms. You cut a pizza into 12 equal parts. You want to eat the whole, the 1 whole pizza. So you're going to eat all 12 pieces. So 12 over 12 is 1. Back to here. So the 2 changes to a 1. It has lent 1 whole to this 4/12. And this 4/12 is going to take this 1 whole as a 12 over 12. So 12 over 12 or 1 whole gets added to 4/12. And now this one is no longer a 4/12. This changes to a 16/12. 12 over 12 plus 4 over 12 is 12 plus 4. That's 16 over 12, right? Minus 9 over 12. And look, now 16 is more than 9. You can go ahead and do the subtraction. And let's not forget, there was a 1 whole before this. Therefore, this is going to be 1 whole plus 16 minus 9 on the top over 12. So that's 1 whole and 7/12. Make sense? Great. I'll see you soon.